Hello, welcome to More Fun Fixing It. I've got another ZX Spectrum here, and this one's a grey +2 128K. This is basically a toast rack with a tape deck. This would be the computer that Amstrad created when they took over Sinclair, or when they bought Sinclair from Clive, and Alan Sugar got people to reverse engineer. Is that the right word? Reverse engineer? Reverse engineer the PCB from the toast rack, and they made their own one, and this is it. So this one you would have seen in a recent triage episode, and I've written on here IC17 bad and DC jack not food. This is in reference to Paul's original, this is a Paul Universal Retro Boss computer, original note here: DC connection not food, black and white screen. I can just open this up. I've actually disconnected everything already, and the tape deck is going to need a good service. That belt there is really baggy and no good. Everything else looks okay. It actually doesn't look too dirty underneath here, so pretty sure that I can get this. Oh, it looks pretty grim inside there though. Oh, yeah, we'll look at that later. And in here, we know that IC17 is bad, but I'll show you that in a sec. I mean, it looks quite corroded in here. The top of the modulator is really rusted. The PCB is fine, and the legs of the chips are fine. There's a lot of dust and dirt around, so I'll give it a... Oh, there's a lot here as well. Yeah, there's a lot of stuff like this in here. It's pretty filthy. Oi, oi, oi. What is that? Oh, there's a previous occupant. Sorry, arachnophobes. It's only the outer shell of a spider. But that was his web. Wonder where he's gone. He might still be in here somewhere. This batch of computers has definitely looked like they came out of a shed somewhere or something like that. There's this as well. This might be where the spider met his end. This could be an exploded spider. Look, I think something's dripped in here maybe. I'm not sure. It could be. I don't know. But that'll need cleaning up before this is finished. There's other things to do in here as well. So these transistors here, bend that one over enough for you to see. Not really. It's a TR7 and TR5 over here. TR5, if I bend that over, that is a 2N3904, and it should be in the other way round. So all of the ones that are like that, there's that one. There's one over here near the modulator. This one here is the same. 2N3904. That needs to be turned around. And yeah, TR7, that one there is the same. I think there's another one somewhere else as well. I thought there were 4 of them, but it seems not. So let me show you the problem with this one, in case you haven't seen the triage episode. If I turn this on, I get absolutely nothing on the bench power supply. It's not drawing anything until I touch the power socket, and then it starts working. So we've got a dodgy power socket for a start, but we've also got something else. Let's take that out before I plug this in, in case it comes to life halfway through. You don't want to be plugging things into an expansion socket with the computer turned on. Oh, that is lighting up. There is a little bit of residual voltage in the capacitors. Shouldn't be enough to cause any damage though. Put this on. Right, so if I now hold that down and let the diagnostics run through, I'll skip through. I always speed these up. I don't put like a fast forward thing on the screen because that's just, I'm a bit lazy. But I always speed these up when you see these in videos. So let's skip to the bit where it says what's wrong. There we go, exactly the same repeatable results as before in the triage episode. So I can I can turn this off now and then we can get to work. So the first thing I want to do is fix that power socket, and then we'll pop a new chip in here and then turn all of these transistors around the other way. Ooh, that doesn't look very nice. There's a lot of flux. I've seen this before. There's a lot of flux in these points. So I think this is factory flux. These points here, I think these are like inductors. And they've got the same flux around them as the joystick ports and these ports along the back here. And I think that's factory flux. These parts would have been put in after this the rest of this was wave soldered. So all of the components would have been put into the board, and then it would have been passed through a wave soldering machine, and all of these points would have become soldered in the wave soldering machine. But all of these plastic parts and these parts with delicate bits inside them would need to have been hand soldered afterwards, and they've just used flux or solder with flux in that has not really aged very well. So this is over one of the joystick ports, and it's this same horrible crystallized mess that we've seen before. The same on that joystick port, but again on these inductors. I think they're inductors. I'm pretty sure they are. Someone will correct me if I'm wrong in the comments. That seems to be a national pastime at the moment. These bits here, that really, look at that. It's basically tree sap they've been using to solder these in, or to flux the joints. There's so much of it. It's basically turned to amber. Trails of it. But over on this side of the board is a chip. This is the ZX 8401. Oh no, it's a 40058. Oh yeah, it has. Yeah, I think this is the same as the ZX 8401. It's a logic chip basically, and this one has been worked on as well. That's been replaced, or it might have been done. It looks like the same stuff as the stuff from the factory, maybe a little bit more corroded, but I think there's some water damage in here as well, and this might have got wet. But that does not look good. So I got told off in, I think it's going to be last week's video, by many people in the comments pointing out to me that I missed a big cold solder joint on the CPU in that Spectrum repair, the Angry Bees one. And yeah, I'm guilty, missed it completely, didn't spot it. But thank you everybody for pointing out what I missed. I have learned from my mistake. But I think what I need to do with this is give it a wash with some IPA. Oh, look, immediately looks better. Look at that. How much better that looks. You have to work at this quite a bit because it's, you know, it's crystallized and you're trying to dissolve something that's been on there for nearly 40 years. There's a bad looking joint there. That doesn't look very good, that one. I'll eat that one. It's solid though. I reckon this was done in the factory. I reckon that was, I reckon they didn't like that, or it was a faulty one on the production line and they took it out and put another one in, but hand soldered it in. Ooh. That's all right. That one's got some black goop over it. There we go. They all look loads better. So I could do these as well. Let's see if these clean up. Last few remnants there. Put that bottle in the way of the light. So I'm not going to spend too much time on this. I'll just give these a quick brush over just to get the worst of it off. I wouldn't bother doing this on my own machine. That looks like solder there. Yeah, bit of factory solder. Right, and then all the way over here, this is the power jack. Ah, yeah, here we go. Let's clean it first. Can you see the problem? So, right, I'm going to grab the jack on the other side, give it a little... Well, that is cracked, but I have to say that... Let's get that flux off my tweezers. That across this side, that's not actually cracked across there. I think it's going to crack all the way around. I think the problem's actually... Yeah, the other side of this is basically falling apart. Yeah, so what we need to do is just get rid of that. Yep, get rid of that and put a new one in. Put a new one of these in. My nozzle won't go over these. Ow! All right, let's try some braid because the desoldering gun's not doing a good job on these big pins. Can't get the nozzle to go over the top. I've got some movement on those two now, so now I can just heat this one up. In fact, that pin's just disappeared. It's broken off, I think. There you go. Let's flip that over and have a look. What's going on? Oh, yeah. Okay. Not sure what that is. Well, that's all right. That's the leg that's broken off. And I think this is just disgustingness. Let's clean that first before I go any further. All right, the pad's still there. That's good. Ah, there we go. All right, let's get that cleaned up. A bit better than that. Not sure what that is. It can't all be flux. That's, I tell you what's happened here. That is flux. It's corrosive flux, and that has corroded this. It might not have corroded these nice leaded tinned pads, but this leg here was made of a different material, and this part of it's protected by the solder, but this bit is the bit where it was connected to the body of the DC jack in here, and the flux has just eaten that away. Probably helped with a bit of, you know, stress over time from being plugged in and out, but that is what's happened to that, I think. Anyway, it's full of it. Just chop the end off of a cotton bud. Just to try. Yeah, I think I've got it all. Oh, it's glue. Someone's glued it down. That's what's happened there. This is all glue around here. Haha. So maybe it just broke and they popped some glue underneath here to try and stabilize it. And that's what's all this disgustingness is. So maybe it didn't corrode, it just broke off after natural use. And this is the end result. Okay, well, I'm happier now. The IPA has made it go all soft and made it easier to remove. A few bits on this side. There we go. A new socket in there, good as new. I'm just going to give this a quick going over with the braid again, just to make sure that all of the old solder is off before I put the new DC jack on there, so that it sits nice and flat. There's no damage to the pad at all, or the pads. Here's the new one, here's the old one. Not sure what's happened to that, whether this one's got a piece of plastic over this bit here, but this one seems to be missing it. Whether that was never there, I don't know. Doesn't sit completely flat. It's not too bad actually. Right, let's hold it in place with some blue tack. So it's nice to get these straight. You don't want them spearing off to one side. Try and keep it so that it's looking to be straight with the board. And I'll solder this middle pad here first, just to tack it and then make sure it's in the right place. Got my extra big 1mm Weller radiolet solder here. Makes this sort of thing really easy. Trying to feed in 0.7mm solder is actually a bit of a pain. That, yeah, that looks perfect to me. Quite a lot of flux comes off of that solder, so worth giving it a little clean. That looks better. So that should give us a nice stable voltage now coming into the board. Let's put it back in here. Oh, that feels much nicer going in there. Let's see what we get on capture. Perfect. Now I can fiddle around with this all I want and it doesn't do anything to the voltage coming in. There's some nice solder flowed up onto the side of the leg there as well. Yeah, I'm quite happy with that. It's a good job, well done. Right, so we've still got the issue of this faulty RAM chip, but I am going to test it again, just in case. Because I learned something in the Angry Bees video, as we discussed earlier, is to change one thing at a time. So let's skip forward. This is about the point where it went red. Oh, interesting. I've learned something new. Look at that. So it was just that jack. It was IC17 was completely blameless in this instance. So not changing two things at once really paid off there. I was tempted. I think old me being me from a week ago, would have changed that jack and just popped that chip out and put a new one in, and then tested it and gone, yeah, that's fixed. It must have been that chip. But new me knows better for this week. New me is a more rounded and whole repairer. Thank you to everybody that commented and pointed out about the dry solder chip. I think Phil Sands got there first. Well, there we go. So all I need to do now is sort out these transistors that are the wrong way around. Right, so TR5, TR4 and TR7 are the transistors that need to be turned around. So they're facing the opposite way to the markings on the silk screen. There are other modifications you can do to these. There are things that improve some of the sound quality and some of the sound levels and things like that. But I'm not going to do any of those. I just want to do these because they're components that are under stress and can go wrong. I've never seen it happen. And the computer still seems to work with the transistors in the wrong way somehow. But I will turn them around and make sure it still works, and then I'm done with this one. I've explained in other videos, but I'll explain in this one again. I'm just here to repair these. All of the other work, I don't want to be, there are 4 of these. I don't want to be doing all of the modifications to every single one of these. Where do I draw the line? Do I clean every single one? Do I desolder everything, clean under all of the chips? I mean, where do you draw the line? I just want to repair these. Paul just wants to sell them. So if somebody buys this, and I'm thinking about putting QR codes on the bottom of the cases on a sticker so that people can see that there's a link to a video, and the QR code will link to the video, hopefully. And then they can, people can look at the video and see what work has been done and choose whether they want to do the rest of the work themselves. And that's entirely up to them. But yeah, that's why I'm not doing every single modification on these that is possible. I've done that before. I don't want to do it again. That's blocked. Speak of the devil, just as I mentioned, Paul, he's just messaged me. That's better. There's one. 2. 3. Before I put them back in, I'm just going to run them through my component tester. Good. Good. That first one gave very different readings. So 1, 2, 3, 1.13 and 660 milliamps. Yeah, that's a very different reading. Let me get a new one. There's a brand new one. It's very different. Right, I'm going to try comparing these 3 new ones against each other and see if they give wildly different results. So 359, 3.25 and 645 millivolts. I've already forgotten what they were. Now that's similar. Yeah, the old ones are actually giving very different readings. I thought that these are actually quite okay, but there's enough difference in those readings that I think it's worth putting new ones in. I've had my mind changed, so I'm going to bin those and put some new ones in. Remembering to put them in the wrong way round. One in there. One in there. Right. Oh, let's give this a quick brush out, actually. This is my Future Was 8-bit edge connector cleaning tool. Does a really good job. I spent ages trying to find the exact right kind of eraser to do this job. I can't remember how I got this now. I think I might have actually bought this from the Future Was 8-bit. And it is exactly the right kind of eraser. Let's test where we are so far. Now I'm looking at a really small capture here, so it's difficult for me to see if there are any problems with it. There might be some jail bars, but again, it does look really good from here. That's as good as I want that to be. And the only things I need to do now, service the tape deck and test the keyboard. Actually, let's test the keyboard. There is a keyboard test built into this, but it doesn't work very well with the... Oh, there's a key stuck down. Let's do that again. Doesn't work very well with the keyboards with the extended functions on. It's for the 48K version, or the rubber key and the plus anyway. Space. That's all the keys I can test on there. Yeah, the keyboard's really crunchy. Going to need taking apart and cleaning. And we need to have a look at this tape deck actually. Yeah, these keys are slopping around, and when I press play, it's getting caught underneath here. That's not turning fast enough. Fast forward is quite slow, and rewind is really slow. So this needs to come out. And sometimes these aren't recoverable. But I will give it every chance. Long screw in there. Very long screw in there. That's nasty. Pretty nasty. Okay, that's slopping about because these two screws have come loose here. Yeah, that's better. Okay, that's solved that. Quite nice and easy to work on these ones. There's a lot more of that flux that we saw on the main board on here as well. Same thing going on there. Don't think it's doing any harm though. It's quite... Don't know if it's becoming conductive though, that's the only thing. If it... there can be some resistance going on between, or some conductivity going on between these points where it's spread across contacts. Most of the time it's just around a single point like here. It's not really, like that's got solder mask on over there, so it's not conducting to that trace, but I don't know, be difficult to know. Let's give it a clean. Looks better. So I also need to clean in here. I'm going to use cotton buds for this though. It's not actually that bad. Let's give the heads a clean. Just while I'm here, it was actually quite dirty, that reed head. The pinch roller down here is not too bad actually. It's nice and soft. Doesn't look like it's got any corrosion, any hardening going on. I'm going to use some window cleaner for this one. It's just a bit kinder on the rubber than isopropyl. All right, take the belts off. Just under here this is the pause mechanism. If I hit the pause button, you can see this moving. And there's a little hat on top of the pause mechanism, and that pops off and comes loose and rubs against the bottom of the flywheel. But this one's in perfect condition, so That is that's a relief actually, because they're a bit of a pain. So I need 2 belts. I'm pretty sure I've got some new of the big ones, but I'll have to dig around to find the smaller one. So these belts came from the Amstrad lot that we got, me and Henry got. So I've got AV belt 114. Don't think it's that. I think that's the, yeah, that's the big one. And then the AV belt 107. I'm pretty sure that's it. Yeah, that's the one. Just enough sproing on it. Lovely. Oh, last thing I need to do is actually put some lithium grease around. Oh, silicone grease I'm using. I'm just putting it in the places where I can see there was white grease in there before. You can't get to all of them anyway, so. Marvellous. It still needs a clean, but that's not my job. Oh, there's one thing I forgot to do, but I can do that with the drive in place, with the tape deck in place. It's not a drive. Clean this leaf switch in here. Just this leaf switch here. A little bit of very fine wet and dry sandpaper. It's almost polishing paper. It's like 2000 grit. Just a brief little rub of the contacts. Right, that's back together. Let's give it a go. Oh, I hear that. It's not a good tape deck. I mean, this part of it is now working pretty well, but that play button is difficult to push down and get stuck under the case. Let's see if it works. Oh, I found the Horizons tape. I don't know if this is a good one, but we can try it. That looks pretty good. Now I can't hear the audio, so I can't hear if it's warbling or not. But the bars look steady, so it looks okay. Volume set correctly. That's working well. Just need to do something about this, the keys not working. I think this has been a problem with it, because I reckon that they've been jamming down on this play button to get it to work, and that's what's made the screws work their way loose. They've probably just ripped them through. Reset doesn't work, so get that out of there. Turn it off a minute. Before I forget, let's give this reset button a little squirt. Right. Yep, reset's working perfectly now. Cassette deck's fine. So what I've done is loosened off all the screws, pushed the tape deck as far back as it would go and tighten them all up to see if that would help. Let's just put it back in and see if, once it's actually sitting on top of the actual computer, what it does. That's better. Probably in shipping it's going to get a knock and it will just end up back where it was, but yeah, it still needs the keyboard cleaning, but I'm not doing that. Let's find another tape and give it another go. Oh, here's a favourite. Jet Set Willy. Don't know if this works. we've got the key for the piracy protection. Brilliant. Let's see what that does. Hey, it worked. Grid location K1. K1 is blue, blue, magenta, blue. 1, 1, 3, 1. What? There we go. Enter. No. Sorry, try code L3. L3 is red, red, magenta, red. So 2232. 2, 2, 3. Oh, it's done 2 again. 2, 2, 3, 2. What? I think because it was doing double key presses, that messed it up. Oh well. It loaded. It works. You're better off pirating software. Especially Nintendo software. No. I'm done with this one. But I did enjoy doing that. It was a very simple thing to fix. It was only this that was wrong. And the tape deck obviously needed a little bit of attention. I'll put the screws in the back and send this one back to Paul. Well, I'm not going to send it back to Paul. I'm going to put it on the pile of other ones that are ready to go back to Paul. And then it will wait till I go back there. Excellent. This is not food. Nope. Oh. It's not food.